How in the world are we gonna, given this cat and mouse hackers game, gonna be able to provide everybody 100% certainty that your robot will never turn on you? Welcome back, everybody. Today, Dad is reacting to a Boston Dynamics release from 3 days ago called Pick, Carry, Place, Repeat Inside the Lab with Atlas. Dad, who loves building robots and working with robots, this kind of material always catches his interest, and he looks forward to diving in with you along for the ride.
Okay, trying again.
All right, zooming in 3, 2, 1.
Right away, I'm just going to say I love that the video starts with, okay, we're trying again. This is the life of working with robots or just engineering in general. You're doing a lot of iterating.
The core reason people are so interested in humanoid robots today is the promise of a truly flexible robotic solution that can switch between tasks and applications in a way that we just haven't seen before in robotics. The world was built for humans, and the huge promise of humanoids is that they will be able to enter into those human-built environments and immediately add value.
The previous generation of Atlas was able to do a lot of really athletic things, from running around, jumping, flipping, and so on.
They will be able to add value. You're creating robots that look like us and that move like us and that can do the tasks that we do. And yes, that could be very useful if they're going to be doing all the jobs I don't want to do, like the laundry, washing my dishes, making my dinner. I just see the parts that move, and I understand some things about the forces involved that these robots can generate. And I also understand about human flesh. And these robots unknowingly can seriously damage and hurt somebody. And that's one of my first major concerns with all interactions between humans and robots kind of working alongside each other and living like with each other, is that you just have the potential for massive amounts of damage and harm. And even if that robot has done my laundry 10,000 times and made my life that much easier, if just one time it takes my kid's finger by accident and gets it wedged somehow between some joint on it and the kid's finger gets ripped off, all 10,000 laundry loads were not worth it for me anymore.
And so that made it a really interesting research platform for us to explore the limits of whole body control. But there are some downsides to hydraulics as well, right? They're very complex, they're quite expensive, they're difficult to maintain, and they're messy. Right? Our old lab used to have a thin coat of oil on it at all times. And we got to the point in our humanoid development where we realized that using the battery technology that we developed on the previous generation of Atlas, and by building our own electronic actuators, that we could build a humanoid that was strictly faster, strictly stronger, and more compact and less messy. Just manipulating objects is something that people spend very little time consciously thinking about. We've had an entire lifetime of interaction with the world to train our control system so that we know how to predict what's going to happen, and we know how to send commands to different parts of our body in order to achieve manipulation tasks. Robots, by and large, do not have that wealth of experience. And part of the exciting work that is happening in AI, and that we're doing ourselves as well, is trying to use the rich data sources that we are generating now from all of our robots, whether they're deployed out in the real world, whether they're in our labs, or whether it's being generated in simulation, in order to train models that have a there in our labs.
Yeah, I like robots in scenarios like this. They're isolated, they're by themselves, they're doing some kind of annoying, laborious work that would probably injure a human over doing it many, many months or many, many years. And those kind of applications, I think they're fantastic.
Generated in simulation in order to train models that have a similar ability to generalize and a similar ability to error correct when trying to do fundamentally new manipulation tasks. And I think that's one of the places where I would expect AI to significantly change how we perceive the capabilities of robots over the next couple of years.
Sequencing is a logistics task in the automotive manufacturing world that was created in order to allow manufacturers to produce many different customizations and variations of vehicles.
Sequencing has commercial value, but also from a research perspective, from a building blocks perspective, has a lot of the complexities that we think are necessary to be able to develop general purpose
It just seems very unnecessary that the robot that you're using to sort these various pieces, into these compartments, has to be a humanoid. I feel like the desire to make it look like a humanoid is only because it's sort of sexy to the eye. Like, everybody seems to be more interested when the robot looks like a person. If it just looked like some kind of R2D2 type of thing that was rolling around on wheels, not as interesting, I guess. Simple is the best thing when it comes to engineering and design, and why they want to make it a robot humanoid that does these kind of tasks. Is it only just to elicit consumer interest and maybe draw in investor funding? Or is there really an engineering design strategy behind it? Like, why is the humanoid robot better than building just some sort of robot that's on wheels that drives around, that has like 2 arms on it that can do this job?
Population robots.
The sequencing process is taking thousands and thousands of different variants of parts and putting them into the specific order in which cars are going to be produced, making sure that the cars can be produced more quickly and more accurately than they were before.
For this task, we've given Atlas a basic description of the end state that we want. So we have this output dolly that needs to be filled with engine covers in a particular order. And we've also given it a description of where it can look to find those engine covers. Once it has this, it basically goes in order of the output dolly. So it picks, say, the first slot in the output. What kind of engine cover do I need? And then consults, where can I find that?
And I think most of us watching this would say, I think a human could do that significantly faster than this humanoid robot. I don't think that's the point. The point is that the robot is actually able to do this. It's responding in real time to its environment, that the environment is not perfect and it can change. And regardless of that, the robot can still figure out how to complete the task. And those are the most difficult, I'd say, types of tasks to program when you're dealing with robots, is unpredictable consequences that will arise, and making sure that your robot can handle those types of events.
That, and then it goes and tries to pick it up from there. And if it can find it, it proceeds. It has that kind of basic description, and then it has a description of the kind of whole architecture of the task that we've provided, and then it puts those two together to do the sequencing.
Atlas has cameras, mostly in the head, and with those cameras, it perceives the fixtures or containers that it has to interact with, not just the one in particular where it has to extract an object or insert an object, but all containers around it, so that it can map its footsteps to avoid collisions, for example. And then at the same time, it also sees objects. It has an idea of the object that it's going to manipulate, and with that mental model, it sort of uses directly RGB cameras to estimate the pose of the object and then equally track it over time.
Sometimes it knows that it's successfully put in place. So it knows that it's failed if it starts pushing.
You're never quite sure, is the robot you're watching perform the tasks under the control of a human with a joystick that's driving it, or is it autonomously just running through a routine that's been put into it? Way more impressive is if there's just an autonomous routine that's placed inside this robot that allows it to navigate this task. If somebody is literally just driving it, another human being, then this is not that impressive. At least as up to this point, I don't feel like the video is stated one way or the other what we're actually observing here.
And senses that it's not being able to move the cover the way it wants to, and then it'll back up and try again. It'll get the cover in and then let go, and at that point it thinks that it has successfully put it in place. It'll go ahead and give it a little extra push just to make sure it's fully seated.
The 360 rotations are funny. They're there for a very particular reason, which is efficiency, right? So Atlas can turn around faster, can turn its head. It wants to look something behind its head, and it can just turn the head. Atlas is faster at moving back and forth because it has that moving back, and it can just turn the head. Atlas to look something behind.
I'd like to see what would happen if a human being, like say a 6-year-old child, were to walk through this area that Atlas is working in. Would Atlas be able to avoid that child? Would it be able to still perform the operation it's doing safely, assuming it's under autonomous control? Oftentimes, the programmers aren't 100% honest with what they're doing. I visited a lab once where they're doing pretty high-end work. The person in charge said that they call in lots of undergraduates to interact with the robot they had, similar to something like this. And they would tell the people that you're going to be interacting with this robot, and everything you're going to be observing is just the robot behaving on itself. It's going to be autonomously just interacting with you. And the people would sit down and they'd talk to the robot and interact with it. And they would be under the impression that, yes, it was autonomously responding to them. But the whole time, there was actually 3 or 4 programmers working and controlling the robot. And the purpose of the study was to observe the human behavior and the human psychology about how humans interact or want to interact with machines. So, in science, that's often done where the test subject isn't made fully aware of the purpose of the investigation. They actually may be completely misled as to why they are there.
In its head, and it can just turn the head. Atlas is faster at moving back and forth because it has that 360 motion.
Boston Dynamics has a very long history in robotics, and in particular legged robots. And in bipeds alone, we've been working on them for probably over 15 years. But we really designed it to be a very high performance machine in 15 years. But on them for Dynamics has a very long history in robotics, and in particular legged robots. And in bipeds alone,
here you see engineers and scientists that are very happy and pleased with the work that they've produced. The guy's double fist pumping, you got authentic real smiles. And I understand this. This is what happens after hours and hours of toil and failure. And when you see it succeed, it really does just lift you up immensely. And these guys are pioneers, and they're pushing the envelope of current technology and what can be done. And I hope they're also aware of the potential risks and downsides, and they're not just blinded by this sort of glamorous nature of what it is that they're creating.
We've been working on them for probably over 15 years, but we really designed it to be a very high performance machine. And so we're interested in, again, being able to explore the very frontier of what's physically possible in humanoids and everything, all the infrastructure in robotics, and in particular legged robots. And in bipeds alone, we've been working on them for probably over 15 years, but we really designed it to be a very high performance machine. And so we're interested in, again, being able to explore the very frontier of what's physically possible in humanoids and everything, all the infrastructure we built around doing that, I think is a real accelerant that shows itself through the performance of Atlas already.
I'm biased. For me, it's the pinnacle of humanoids today. It's capable of all of the agility that HD Atlas had, but probably even more than HD Atlas.
It kind of reminds me of watching a toddler learning how to do something. And I think that's a decent analogy for where we are in time. Robots look like 2-3-year-olds navigating around. We all understand and know that give them 5, 10, 15, 20, 50 years, that is just going to blow our minds, like what these humanoid looking robots are going to be able to do. We're being introduced to these robots in a really safe and slow manner. They're slowly being, hey, everybody, look at these nice robots. Look at these cool tasks that they can do. And they're going to be such big helps for everybody. And that's what's going to allow us to start accepting them into civilization and into society. And we're going to all be okay with them working at cocktail parties and serving us drinks. What if they're law enforcement robots of some type or military robots of some type? And then you start to get really different sort of thoughts on things. I'm curious what the viewer who sees my video here thinks about this. Is this something that human civilization should be pursuing at a rapid rate? Should we be trying to accept humanoid robots into our daily lives? Or do you have concerns? Regardless of the concerns I have or that you may have, I think that this is here and you can't stop it, and it's going to continue to advance. And I only hope that it's going to be used for good and not for evil. I'll leave you with a thought. So if you can imagine a time in the future where perhaps everybody has one of these humanoid robots in their home. Let's say that each one of us has been trained to teach the humanoid robot how to perform tasks that are useful to the person who owns it. So I might be teaching it at my house to sweep the floor in my garage, or put away the dishes, or sharpen knives. Say another 100 million people are doing the same thing with their robots. And the powerful part about this is that all of the, say, 100 million robots that might be, say, in America could actually share a common brain. So that if somebody in Seattle teaches their robot how to do something, somebody on the other side of the country in New York's robot will now also be able to do that. And that becomes extremely powerful. It also, again, raises the red flag of what if someone were to put something out there that wasn't good for humans and pushed it to 100 million robots in some way. You can't stop the hackers. It's just an endless game of cat and mouse. And that's just a philosophical argument that I've been told is the way things are. And it's not going to change. So I look at anything like this, and I think about 100 million of these robots living in 100 million homes in America. And I think about hackers that might be trying to cause harm to people. And that gets me extremely concerned. I don't think I'd ever want a robot like that in my home that was continually linked up to some sort of like central Borg brain or some kind of central command center where somebody could push commands out to the robot in my home that could possibly do harm to me. And I think that's a serious concern that everybody should be thinking about. If you have a robot and it's living in your home and it's connected to the internet in some way, how in the world are we going to, given this cat and mouse hackers game, going to be able to provide everybody 100% certainty that your robot will never turn on you? And I don't see that as there being any guarantee that that can be done. And so for that matter alone, I get very scared about this, and I wouldn't necessarily ever welcome one of these into my home. I'll see you next time.